Hello, and welcome to Plafunga Programming. This YouTube channel, for those of you who don't know, was only created to document some of my projects, for others to gain inspiration from, and even make better versions of it. For example, we'll start with this one right here, Happy Donut Game. This game here was created because I doctored out an infrared sensor out of a broken DVD player, and found an old broken remote. And I decided, well, what could I do with these? I'll just make a game out of it, because it's like a game remote, that's what I thought. I'll show you it right now. So the object of this game is to eat the donut, which will appear on this. And you use the arrow keys on the remote to move the smiley face around the screen. When you get above the donut, you can press the enter button, and it will eat the donut, per se. And you get 1 point. But the thing is, before you've got above 3 for the first time, you can't lose points. But once you get above 3 for the first time, you can now start losing points when you miss the donut. Like that. Now, the object of the game is to get 20 points. But as you get more points, the donut will move quicker and quicker. As you can see now, the donut's moving a lot quicker, which gets harder. What I find when I'm playing it is that once you get to 19 points here, it just becomes a lot harder to get the donut. Just another step harder, it feels like. But that's just me. Now, once I can win, which is really hard. I've only won this game like 5 times. And considering I made it, that's kind of sad. Say I won, I'll put one of the little cheat the 5 on this remote is extra 5 points, because that was just an experimental feature while I was trying to get the donut to go quicker. But once you get to 20 points, you get to this screen. And when you lose, you get to just a moment. Just have to turn it on and off again. When you lose, you go to this screen, which is when you go below 0 points, you lose. That's the basic version of the game. There's also a mute function, so that there's no noise coming out of it, because the noise can get annoying sometimes, and a pause function as well. So we start with including the libraries. Because we're using Arduino, there's no extra libraries or anything like that. For example, like in the ESP8266, you need a ton of libraries for each different remote type. And now then we have this constant integer receive pin, which the receive pin, it's set to 12. That's the input pin from that's the input pin from the infrared sensor. Now in this line we're initializing the LCD. And then this line here is kind of saying to the program, receive the infrared stuff from the infrared receiving pin, which is set to 12. It says this decodes the results from hexadecimal for like F8897C, which is, that is, hexadecimal is like we have base 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hexadecimal is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, A, B, C, D, E, F, then 10. Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, then 10. Next line here is the key value, which I'll get to a bit later, because there's a bit later in the code, there's a use for that. The seconds, well, I'll also get to that later. Backlight pin here, that backlight pin's controlling the backlight of it, so I can have an on and an off function. This BL off defines that the BL to turn it off, turns the screen on. BL on turns the backlight pin on and makes the screen turn on. This number, it's used a bit in the speed of the donut. Loop number, all that was used for was, it was to say at the end of the first loop it's set to 1, and I can't remember what that was for. I'll probably find out later. I haven't gone through this in a while. This byte here, that's the happy. If you look at the ones, there's a 1 here, one here, here, and there's 3 ones here. If you look at the shape of that, you can see it's a smiley face. That's because that's what it is. It's the happy smiley face. Happy up is the same smiley face except one thing up, used in the eating the donut and in the winning screen where the smiley face goes up and down. The donut here, this is just the ordinary donut. It's sitting on the ground, so that's why it's down. And this is the donut up. The donut up is where the donut is, like on the winning screen, it jumps up and down, that's what it's used for. And finally, the sad face. That's the losing string. Now here we go, lots and lots of variables. Columns and row, that's the column and row of your smiley face. The X integer here, I'll get to later. Going above 3, well that's set to true once you've gone above 3 the first time, but it's set to false when you reset. As you see here. The win score here, it can change. The string here is what's displayed on the screen, and the lose score is, well, how the score you when you lose. If you set it to 1, you'd lose as soon as you start, which is why it's not set to 1. The donut, because you start on 0. Here you go, have donut col and donut row. The donut column is set to a random integer. This is only the first one through though, but the row you've only got like the columns is set to random and the row is set to 0. So when you start, you're always in the same row as the donut. Your score, the menu is set to 0 because that's set to 1 when your menu is on. The pause function here is because when you press play for the first time, it's saying press pause play to start. But when you press it the second time, for a second time, it will say paused. That's indicating only when so that works. That's set so that can work. It's set to 1 when you go through the first time. The level here is set to 1000. I can change that so it'll get quicker and end at a quicker speed. That's used in, but eventually I will put in a function so that you can go to like a settings page and you can change the difficulty and it'll change what this number is set to. The piezo, that's the pin the piezo is on. The Boolean sound, that's so I can use a mute function when sound equals false. Well, it doesn't go. Here you go, void setup. Here you have the pin mode, piezo output, setting that up, setting up serial, infrared receive, enable IIN is basically saying enable it's pretty obvious, enable infrared input. LCD beginnings, initializing that. The pin mode, that's setting another pin, the backlight pin, turning the backlight off at the start, making sure, because when you turn the backlight off, you can still see the characters, but they're very dull, so no display, make sure you can't see the characters. Now here we just initialize all the characters, and then we set the cursor to the column in the row, which is where your smiley face is, and we write the smiley face, and then the donut column, donut row, and then we write the donut. And then we always set it to the column in the row. Now what that does is when you press, like when it turns on, you're supposed to be able to see them, but it's kind of useless now. All these lines, you don't really need them. So A and B use those variables there, the last two variables. They're used in when the donut's moving, and it's defining because A is there's 3 rows. There's 3 so 0 to 3 you can go left or right because it'll be set to 1, 2. Hang on. A is like whether it's going. This is going whether it's going up or down. This is going whether it's going left or right or not or none. Because if it's going left or right, it will go left or right or it goes up or down. So your void loop here. Now, if that's that there, if you can read programming, that's basically saying, well, it's that's going when you're going above 3, set it to true, and then you have your menu block. If the menu equals 0, this is the entire menu block, if the menu equals 0 or false, and then you go to another loop, if x equals 0, you clear the LCD. That's what the x variable is used for. It's only clearing the LCD the first time. It's so when you clear it, if you have that LCD.clear, say around about here, just in it, when you go into the menu screen, you just flash and it doesn't look great because it's clear. It has to clear. It's clearing every single loop. So this, make sure it only clears the first time, only clears the first time through, and on its way out, it just clears. And then LCD.clear is clearing the screen. This is set cursor to 0, 0, print happy donut game. If you're paused, if it's set to pause, if paused is true, then it goes to the pause screen. But otherwise, it will say press play, which is what you saved at the start. And then x++, which means x will equal 1 now. On the next rotation through, x equals 1, so you don't clear the screen. Then, on your way out, but in all of these, so if we scroll down to in our switch block, which I'll get to, it's always an x equals 0, which means that when you press any of the keys, it will clear again. It will clear. If you press any of the keys, your pause will still be true. Like any of the arrow keys, your pause will still be true, and so it'll clear. And that prevents any of the little issues of you can still play the game when you're in the pause menu. Prevents those sorts of glitch, which it doesn't properly do that, but it does kind of make sure you can't really see it. Now, after that, you get another. This is now in the loop, so this is always changing what A and B equals. And then this is what this does. If your score is less than the lose score, so which means you've lost, or results and the results value is what your results is. What the once you've decoded once the Arduino decodes the input from the infrared sensor, it puts into the results variable. And here's the hexadecimal. 0x, I don't exactly know why it's there, but it has to be there. The hexadecimal code is FF4AB5. So what it will do is if x equals 0, it will clear the screen like that, like the one above. And that's basically printing the you lose screen. And yeah, that's that one. Now if you win, or that one, that button, it'll do this basically does every 250 milliseconds, it will change between up or down. It will go up and down. Every 500 milliseconds it goes up, and it has done one rotation of up and down because there's two of them. And it'll do an LCD, always does an LCD.clear, which means that you don't get like a smudge almost of the characters. Next thing in this is this. I'm not going to select it all because that goes right down to the bottom of this if loop. Now what's this doing is it does the infrared receiver and decodes into the results variable. If the results is 0x, so when you press and hold a button, any of the buttons on the remote, it will send the code and then it will just send FFFFFFF. So what this does is when you get FFFFFF, and when the key value doesn't equal, no idea what that one is, you set the results to key value, this is what key value is useful for. At the very bottom of the loop, it's set key value to results value, whatever the previous results were. So when it goes back up to the top here, or wherever we were, down a bit, when it gets back to here, if you get FFFFF, the previous key was whatever it was. This is what the previous key, that's what the previous one was. And so it will set that to the previous one, but the key value doesn't change won't change until this is not FFFFF. Then the key value will change to whatever, and then it will go. because that result change results dot value to key value is I can't remember where it is. So and then you set the LCD to column and row and clear it, and you clear the screen. That's now in the switch block. The switch block is basically so you don't have to have all the ifs, and so you just have case. It assumes it basically does results dot value equals this. You set x to 0 so that it will clear all the menus will clear the screen. Now, if this is the on-off function, so if the pin if it's high, as in if the digital read bell pin is high, what it'll do is you just set it to you set sound to false, which means that sound is off, so you don't and then you set gone above 3 to false because you turn it off. It will reset. It's basically resetting a bunch of variables. And this tone stuff is the da 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 sound. Now, else is assuming that your thing is previously, and also what it does is that it does the LCD.noise display and BL off, so that turns it off. And if it's off though, which is assume is the opposite, like is the else, which means it's off, it'll turn itself on. And like LCD to display, set cursor, write all this, do the sound. And it sets sound to true. The reason this one sets sound to false is so you can't make the remote make any noises. Because you can, because when I didn't have that in there, you could turn it off, and when you press the arrow keys, it would still make the noises and everything. And the menu button, it would still make all the noises. And you're technically still playing it, kind of. Now, break the end of the thing. This is the pause play. What it'll do is it'll do the sound to set the sound to true. If sound is true, this is how you do the if the sound is true, you'll make the sound of the pause menu. And it waits, and it always has a delay at the end of it, so you can't so when you press the button, it has a delay at the end of it, so that it doesn't glitch the thing out, the Arduino out. Set X to 0, at the start of each menu block. If menu equals 1, it will do the menu equals 0, so which is basically making sure you can toggle between paused play and not, between paused and not paused. And if loop number, this is where loop number comes in, does not equal 0, paused equals 1. So that means at the end of the first loop, at the end of so at the end of the first loop, way down the bottom, it's the last line, it says loop number equals 1. What it'll do, way back up here, where are we? Let's find it again. If loop number does not equal 0, so basically, if you've gone through once, if you've gone through the loop once, and so now that you're pressing, now that you've pressed pause play once, if you've gone through, and now that you've pressed paused again, so you need to pause the game, it won't say happy donut game, press play to start, or whatever it says. It'll say paused instead. And then it will, and otherwise it will set the column to 1 and the row to 0. And this is the else loop. If menu equals 0, as in if menu, if you're going back to the game, it will initiate everything. What I haven't gone through yet is the score thing here. This is how it prints a score to right align it. If the score is less than or equal to 9, it will print a space. So it sets it to 14.1, which is 2, so you can fit a 2-digit number in there. You print a space though if you're less than 9, so that you're right aligning it effectively, and then it will print the score. But if it's not less than 9, it won't print the space in there, so you can put the 2 digits there. Then break, and then here's the up key. It's pretty simple. and it's the same for the rest of the keys. You're going x equals 0, like always. Your row equals 0. That's basically because your down is saying row equals 1. This is saying the row equals 0. You clear the LCD so you don't get a smudge, and set the cursor to that. In every single one of these buttons is this. Write the donut, and set the cursor to 14.1, write the score, set the cursor to column row at the end of it, and make a noise. And delay 75 is because if this sound is muted, you'll glitch it out because there's not enough delay. So just always but you also need to, every time you make a tone, this is how long to make the tone for. It's not a delay function though, so you always need the delay after it, so you don't get a straight long noise. You'd get, because when you press and hold, it will do like when you're pressing and holding the arrow key in a game, or whatever key is like left or right. It'll keep on going. So it doesn't make a continuous beep as well. It actually has a break in the beeps. The next thing is your left, and then if column equals 0 this is so you don't go out the left or the right of it. Don't go off the screen. And it's just column equals minus 1 because that's left. LCD set cursor column rows. Right by 0, write the donut. Print the score, make the sound. That's about it. Enter does what it'll do is it will jump up and down to make it jumps up and down, which is all this, and then it will verify. Then this is verifying if the donut's been eaten or not. It sets the donut into it puts the donut into a random spot, which is this. And then it will write, and then it writes the donut, makes a score go up 1. Score equals whatever the score is modulo 100, which means that whenever you go above 100, it will reset itself back to it will go back to 0, which I don't know why that's in there because you don't ever get above 100. Although I did manage to one day glitch the game out, so I did actually go above 100. You set the cursor to 14, you write the score, and if the sound equals true, which means it's not muted, you make the noise. You make the happy noise. Otherwise, that's if you eat the donut. Otherwise, if you diss the donut, it will still go to a random spot. If you've gone above 3 once, it will subtract the score. Print the score, and make a C natural, which is it's in an A major key for those music nerds. It's in A major, but which has a C sharp in it. But it makes the C natural, which is the A minor, kind of A minor third. Like it's a minor third of A, so sounds sad. Which is why it kind of, if you miss it, it makes a sad noise. And it does the beep twice. So it does a short beep and a long beep, and then it's delay 150. Set the cursor to the column row, x equals 0, and then right's the same as left, except you're adding it this time instead of subtracting. Down's the same as up, except you're setting the column to the row of 1. And then here we have 5, which is just a little Easter egg, which I will get rid of when I put it onto an Apple TV remote. 5 is just you add 5 points, and it still has a button and this is the mute button. It basically toggles sound equals whatever sound is not. If sound equals true, make a noise, makes a C sharp or something like that. No, an A. If sound equals false, makes a C sharp. C natural, which is again the minor sets down SATA. And then key value is results value, explained earlier. And then you always have this IR receiving. You do it as resume. You do resume. And then number equals score. There's a lot of debugging in this because I had so many problems making this work. So your number here, is what equals score, whatever score equals. This is so I didn't have to turn score into a float and make it and then it's displaying like say you're on 5 points, it'll be 5.0, which is really annoying. So I had a separate variable for number. If score is greater than 4, so this is so that when you go 4 points, your donut's always at the same speed and it doesn't increase speed. Once you get to 5, then it will increase speed. So your number is, so this is increasing speed. So your win score, there's a bit of maths, so your win score, which is 20 in that case, multiply it by 2, and divide number by that. So say you're on 5 points, you're doing number equals 1 minus, so you're getting quicker and quicker. So when you're on 5 points, it's 5 over 40, which for those math nerds out there is 0.125. So we're going 1 minus 0.125, which is 0.77 or 8, which is 0.875. You probably worked that out quicker than I did. And so that's your number equals that. But when you get quicker and quicker, your level is 1,000 times the number, so you get a whole number, by the way. So when you get when you get more higher scores, so say you're on 15, your number 15 divided by 40 or whatever, 16 divided by 40 is easier, but that's a bigger number. So you're doing 1 minus a bit bigger, so you get to 0.5, and then so that's a lot less of a number, so the delay therefore is a lot less. And this is so that you don't have a problem with having a delay function in there. So you still have the program's still going. It's seconds equals millis divided by level, modulo level. So say your level's 5. Well, no, your level is 1,000 to start with. Like that, that's just starting level. Your millis divided by modulo level. So say if I wanted to say the level once, when it increases to 1500, say, you do every 1500 milliseconds, it will go back to 0. But at the start, every 1000 milliseconds, your level will go back to 0. Actually, hang on, your level decreases, sorry, doesn't go above, it goes, say, once you're up to 500, your level decreases, because it's a 1 minus. So once you get to 500, once your level equals 500, say, it will do 1500, it will do, say, every, say, 500 milliseconds, this variable will go back to 0. Then if you haven't lost or haven't won, which is that's what it's saying, I did a lot of trying to get stuff to work. If seconds equals 0, if your seconds equals 0, which is only happens it goes back to 0 every whatever your level, whatever this is. As I explained earlier, it will it does this if a equals 1, which is one of, remember, our two random numbers, and donut col is, well, it's on the screen. Then you add your donut column, add one donut col, which means just go right. And if a equals 0 and donut col is as in it's not off the screen, you subtract. And then if a equals 2, donut row equals B. So it means it's only going left, right, up or down, depending. So your donut row, so B is the random between 0 and 1. We'll do those two numbers. And then I did a bit more debugging there, which I've got. You clear, you set the center common row, write the happy space, donut call donut row, write the donut. This is in the and then print the score, and then your loop number equals 1. And that's the program. Make sure you head to plafungaprogramming.eu5.org for more videos and to find the programs. And thanks for watching.